I'm not really sure. Do you want to ask Miss?
Yeah.
Okay.
Bob, and this is yes, Samara, what is it?
Miss, I don't really understand what the pendulum is. What is it about?
Let's start from the very beginning. Galileo once said that curiosity is the key to problem solving, and so let us embark on this benevolent odyssey to go through the stretches and swings of a simple harmonic oscillator known as a pendulum.
Oh, Miss, we did some research.
Yeah, we found some pretty amazing facts.
Why don't you come up in front of the class and tell us all about him then?
Galileo lived from 1564 to 1642. He was an Italian astronomer, physicist, and inventor.
Galileo was also best known for his discovery of the pendulum.
Galileo was sitting in a cathedral as he began to observe a lamp swinging side to side from the ceiling. Inspired by the lamp's movement, he began to explore and experiment with the movement of the simple harmonic oscillator, what we know today as a pendulum. Galileo proved with a series of experiments that amplitude has absolutely no relationship to the swing of the pendulum.
What is a pendulum? A simple pendulum is a point of mass that is suspended from a string or rod of trifling mass. To determine the period, we need to count the number of oscillations. Some examples of pendulums that you can find in everyday life are metronomes, clocks, seismometers, and amusement parks and rides.
Hey miss, based on curiosity, we felt that there was no way it was possible that amplitude could not affect the period. After all, the higher you swing it, the faster it must go, right? Should we set out to confirm or find otherwise? Like, not only for amplitude, but also for other variables like length and mass?
Yeah, sure. But Miss, how do we actually do the experiment?
Well, that's a good question, Samira.
We should set up our experiment with a clamp and boss head attached to a retort stand. The string should be tied to the pendulum bob, and in this case, the mass. We should do 3 replicates for each of the 3 trials for each of the 3 variables we want to change. This should confirm that we had valid results. The following graphs show the relationship between all the variables and time that we should theoretically get after doing our experiment like listed above. We can clearly see that amplitude and mass have irregular patterns and therefore no relationship. However, length is a different story.
As you can see here, length has a clear relationship with the trend line or line of best fit. However, we can see some problems with this, including the fact that the line does not go directly across to 0. We fixed this issue by linearizing the graph. There, that looks more like it. We then did some simple calculations to compare our data and how close it was to the Earth's gravity. And we were only 0.403 milliseconds per second squared off.
Thank you for joining us on part of our adventure.
We hope you enjoyed.